Make predictions with quadratic models, part 4. We'll begin with an example. Example 5. A batter hits a baseball into the air. The height in feet, h equals f of t, of the baseball at t seconds after the ball is hit is given by f of t equals negative 16t squared plus 96t plus 4. Number 1. What is the independent and dependent variables? Number 2. What is the h-intercept? What does it mean in this situation? Number 3. When is the baseball at a height of 84 feet? Explain why there's two such times. Number 4. When is the baseball at a height of 148 feet? Explain why there is one such time. Number 5. When is the baseball at a height of 150 feet? Number 6. Use the calculator to estimate when the baseball will hit the ground. Solution. The independent variable is t, the time in seconds after the ball was hit. The dependent variable is h of t, or h, the height, measured in feet, of the ball. The height of the ball depends upon the time when it was hit. Number 2. The h-intercept is, it is the value of h when t is 0, so substituting 0 in for t, we have negative 16 times 0 squared plus 96 times 0 plus 4. And this gives us a value of 4. So the h-intercept is 4. So what does this mean? This means at 0 seconds, when t is 0, the height of the ball is 4 feet. So this was the height of the ball when it was first hit. Number 3. Since the questions 3, 4, 5, and 6 is asking when the ball hit the ground, that's at a height of 0. Ask about a certain height, the dependent variable, it may be a good idea to construct a table of values by using the table command on the calculator. We have the function in y1. I'm going to hit graph and see what the graph looks like. This is hard to see, but it looks like we see part of the parabola here, and then we see where it's coming back down here. Let's look at our table. Second in graph. At 0, the height is 4. We just calculated that. At 1 second, it's 84. 2 seconds is 132. Looks like it reaches its peak at 148. And then it starts coming back down. So just by looking at this table, we can see there is an x-intercept in between negative 1 and 0. And there's another x-intercept in between 6 and 7 seconds. Let's use these values to set our viewing window. So I'll go to window. There was an x-intercept between 0 and negative 1. So let's let the x-min to be negative 2 and the x-max be a couple more than 7, let's say 9. The highest was 148, so let's go to 200. And I want to see the x-axis, so I'm going to let my y-min be negative 20. We'll see what that looks like. We're going to count by 25. We hit graph. And here we have our parabola. And this matches what's in the table of values. So it reaches a peak of 148 at 3 seconds. We can verify that on the graph. I'm going to use the value command. So at 3 seconds, we have a value of 148. At 1 second, we had a value of 84. So 1 second after the baseball was hit, and again at 5 seconds after it was hit, the baseball was at a height of 84 feet. This makes sense that there's two times because the baseball reaches 84 feet both on its way up and on its way down. Number 4. So 3 seconds after the baseball was hit, we had a height of 148 feet. That was the vertex. It makes sense that there's only one time if the baseball reaches a height of 148 feet only at the top of its climb. Or in other words, if the vertex of the parabola is 3,148. Number 5, since the maximum height of the baseball is 148 feet, and we know this because A is negative, it's a maximum at the vertex, and the vertex was 148 feet. The baseball does not reach a height of 150 feet. It can't go higher than the maximum. Number 6, when the baseball hits the ground, the height, h, is 0. So we want to estimate t when h is 0. Or in other words, we want to find what are the t-intercepts. So we want to compute when is h equal to 0. Now from the table, we saw a sign change in between 0 and -1. So there is a t-intercept that's negative, but in the terms of this problem, that doesn't make any sense. At 0 seconds, that's when the ball was 4 feet. So a negative time wouldn't make sense in this problem. But we did see a second t-intercept between 6 seconds and 7 seconds. So I'm going to go to table set, start at 6, and I'm going to count by 0.1. And that way I can be a little bit more precise when the sign changes. And here we can see it's between 6 and 6.1. Let's count by 0.01. And here we can see there's a sign change between 6.04 and 6.05. Because 6.04 is closer to 0, that is going to be the time rounded to 2 decimal places. So what does this mean in the terms of the problem? Well, according to the model, the baseball will hit the ground in about 6.04 seconds. Consider the following observations about a quadratic model, a parabola, and a quadratic equation. In the previous example suggests that the baseball reaches each height either in 2 times, 1 time, or never. Here we have 2 different times for one y value, 1 height. Here we have 1 height when it reaches its maximum. Then in the case of 150, that was larger than our maximum, so here we do not have an intersection. And this is the same for x-intercepts. We can have 2 x-intercepts, 1 x-intercept, or 0 x-intercepts. Thanks for watching.